Hello everyone, welcome to another ComputerCraft tutorial. Before I start, I want to give a quick shout out to a certain YouTube channel. I had been following the tutorials made by Making Games with Ben to learn how to code in C++. His tutorials are really good, and these are what inspired me to start making my tutorials for ComputerCraft. Every once in a while he'd do these game challenges, and just like him, today I will give you guys your first coding challenge. Let me explain how this works. First, I'll give you a list of instructions. Some instructions are optional and some are required. After I finish giving the instructions, pause the video and go ahead to create your own program based around these instructions. Once you finish your program, if you want, you can upload your code to pastebin, like I showed you in the last lesson, and post a link to the pastebin in the comments section of this video. This is not a quiz or a test, and you will not be graded for your work, and you do not have to participate in this challenge. This is merely a specialized task to help you practice what you've learned. However, if you want, I can give you my own feedback on the program you've written. Typically, the less code you have for any operation, the better. But there is no truly correct way to write a program. Just write it how you think it should be written, and I can give you some pointers if you'd like. The material you need to know for this challenge will be linked in the video description. Once you are finished, or if you are stuck and need help, you may unpause this video and see how I will make this program. So, here's what I'll have you do today. You're going to create an item shop that is selling some items via a text-based system. They can be any items you want, but it needs to have a minimum of 4 unique items. The items each need to have a price tag, which can be set to whatever amount you feel is appropriate in whatever currency you want to use for the items you're selling. The user is playing as the customer, so allow the player to give input to decide what to buy. The player may buy any amount of one item per transaction. Give the player an inventory in which you can hold the items you buy. You obviously wouldn't have an infinite amount of money to buy whatever, so give the player a limited amount of money that will be drawn from when a purchase is made. As such, you shouldn't be able to buy more than you can afford. And finally, at the end of the transaction, print something to the screen to show that the correct balance has been drawn and the player has received the items they purchased. And now for the optional instructions. Give the shop a limited stock of items, and do not allow the player to buy more than the shop has in store. Give the player a minimum of 4 already owned items, and then create a process for the player to sell their own items to the shop, similar to the player buying items. Obviously, don't allow the player to sell more than what they have. The items should be added to the shop's inventory since it wouldn't just disappear. Then finally, just like for buying, show a message at the end that shows the transaction was completed correctly. Take your time when writing this program. Remember, it's not a quiz and there's no time limit. And I know I've given you a somewhat hefty task for your first challenge, so take as much time as you need to finish it. Don't forget to save your program frequently in case something happens, so you don't lose all your progress. You may now pause the video, and good luck! Okay, since you've unpaused, that probably means you've finished and you want to compare your program to mine. Or you're stuck and need help, or you just want to see how I did my program. First, I'll make a variable called player wallet and give it a value of 3,000. This represents how much money the player has to spend. Next, I need to create a variable called player items that will contain whatever items the player has in their inventory. For now, I'll leave this empty, as the player is not carrying any items. Next, I'll create another table variable called shop items that has all the items in the shop's inventory. I'll get some random Minecraft items as keys and give them some arbitrary yet appropriate prices as their values. This should be all the variables we need for now, so let's write the actual program. First, the shopkeeper should be polite and welcoming to any customer that walks in. So I'll print to the screen, "Hello, welcome to the shop. How may I help you?" Next, we should print the options that the player has to choose from. I'll print a number in front of the option to represent what the player has to input to choose an option. Right now, the only 2 options the player has are to buy something from the shop or leave the shop. In other words, exit the program. I'll print this instruction here so the player knows they have to type a number input to select an option. In order to process the player's input, I'll need a variable to store it in. This option variable will take the user's input via the read function. I'll also wrap this inside a to number so that we can be sure the input given is a number. If the input given is the number 1, then I know the player wants to buy something. So the shopkeeper should say, "Sure, allow me to show you our wares." Now, to show the player what the shop has, we could just have it print each item in the shop's inventory, but if you remember my lessons about for loops, this is a bad idea. You're showing all the items with multiple print functions when you could show all the items with just a single print function. Plus, doing it this way doesn't account for any other items that the shop may add to their inventory. The better way to handle this is to use a generic for loop to go through each item in the shop's inventory. In the print function, I'll use a greater than symbol to indicate that this is an item option. I'll concatenate that with the element key, which is the item's name, followed by a hyphen and the word cost, followed by the element value, which is the item's price. After the loop is finished, I'll print an instruction so the player knows they need to give an item name to select an option. To get the player's input here, I'll just reuse the option variable from before because it will never be used again after the if statement anyway. I'll set this equal to read, and this time we won't use toNumber because here I'm trying to get a string input, not a number input. Check if the shop has the option that the player input by using if shop items of option is equal to nil, then. I could also write if not shop items of option then, but the problem here is if a value is equal to false, the statement will be valid. Not that any value in this context will likely be a boolean, but for better security and because I want to check specifically if the value is equal to nil, I will write it this way. If shop items of option is nil, that means the shop doesn't have the item the player is asking for. That will be either because the player asked for something that is not in the shop items table, or the player misspelled or miscapitalized or mispunctuated the name of an item. There's a way to check for capitalization, but I haven't covered that in my lessons yet, so I won't be doing that. In any case, if the player gave an invalid input, the shopkeeper should say, "We don't have that in stock today." If the player gave a valid input, then under the else statement, the shopkeeper will ask, "How many do you want?" Now I need the player input again, but I can't reuse the option variable again. This time the option variable is holding information we still need, so we can't overwrite it again. This time I'll make a new variable that is equal to toNumber read. Next we need to check if the input is a number, or if the input is a number less than 1. If the player says they want to buy 0 of something, they're not buying anything. And if the player is buying a negative number of something, well, that's just not buying at that point. The player also can't buy Apple name tags. That's not a number. The shopkeeper will think you're crazy. At this point, the shopkeeper can't allow this transaction to go through, so they should say something like, "You can't buy that many options." Multiply the cost of the item by the quantity, shop items of option times quantity, and check if that is greater than the amount of money the player has in player wallet. If the player can't afford it, then the shopkeeper says, "You can't afford that many options." Else, I'm going to give the player a confirmation of their order by saying, "It will cost this much gold for that many of that item," printed like this. I'll actually change this to a write function because I want to add more to this line of text. If the number of items is not equal to 1, I need to make sure I'm naming the item in the plural tense. If it's a singular item, this will be completely skipped, but if it's not a singular item, we need to write an S so the sentence almost grammatically is correct. After that, I'll finish the sentence and ask, "Is that okay?" I'll give the player a final instruction so they know they need to type a lowercase letter y or n for yes or no to confirm the transaction. Truthfully, the whole transaction will be cancelled and nothing else will happen if the player inputs anything other than y, so I only really need to check if the player's input is y. The confirmation will be taken with another new variable called confirm. To complete the transaction, let's subtract the cost from the player wallet minus shop items of option times quantity, then we need to add the item to the player's inventory. If the item doesn't already exist, we need to create the item in the player's inventory by creating a new key with option and set it to 0. Then we can add the quantity to the player's inventory. Actually, I forgot to do something very important. When looking at the items available, the player should be able to look at their wallet to know what they can afford. I should also let them look again when confirming the order. Back to where I was, let's show all of the changes that have been made by printing the player's wallet and the item quantity currently in the player's inventory. This is to confirm that our program works correctly and the correct values are in the correct places. No matter how the transaction ends, at the very end the shopkeeper will say, "Thank you, please come again." The program should now be finished, so let's save and exit and see if it works. Okay, right away we got an error message. I'll be going over error checking in detail in the next lesson video, but for now I'll give you a quick rundown of this error message. First, you can see we got the name of the program that threw the error, which is our item shop program. Then we got the number 35. This number is the line of code in the program that threw the error, so it's that line we probably have to fix. Then it says equals expected near 2000. This means somewhere in the code we've written 2000, and the program thinks there's supposed to be an equal sign there. That might not be what's actually wrong, so let's go in and check. I actually did forget to put an equal sign here. Alright, let's try to run this again. And it works! Now I need to play through the program to make sure everything works the way it should. If I type 2, it should exit the program. If I type anything else, it should do the same. Now let's try to buy an elytra. I only want 1, and of course since it costs $1 million, I can't afford it with only 3,000. Let's try again, and this time try to buy an iron helmet. They don't have that item in stock, so of course it won't work. Now I'm going to try to buy something that I can buy. I'm going to try and buy apple bottles of enchanting. You can't buy that many bottles of enchanting. Okay, what about -5 name tags? The shopper now thinks I'm insane. Alright, let's try to give some valid inputs now. I want to buy 5 health potions. Okay, that goes through. Actually, I changed my mind. I don't want 5 health potions. I want 10. And if I say yes? The transaction didn't happen. Well, this is obviously an error, but the program didn't give me an error message, so I have no idea what went wrong. To solve this error, I have to use my head. So the place where something went wrong has to be where I give the confirmation input. So let's go into the code and see what's going on there. Aha, here's the issue. I'm supposed to compare the confirm variable with the string y, but instead I'm comparing it to something called y, which is something that doesn't actually exist. You see, the syntax and logic in my code was all valid, which is why we didn't get an error message. But this simple mistake caused the program to not work as expected. Something I also forgot to add was a new line to separate the different parts of the dialogue. But it's no big deal. Now, if we try again, everything should work just as expected. Alright, now let's go over the optional instructions. Since I'm giving the shop a limited inventory, let's split the shop items table into subtables. The item prices we already have should go inside a key called buy price. And then I'll have another key called stock, which will represent how many of each item the shop has. I need to make sure I update all the places in the code where shop items is called in order to reflect these changes. If I leave it as it is, then this for loop, for example, will go through the subtables in shop items, but not the values inside the subtables. What I mean is, A will be the key, which is a string value as it should be, but B will be a table value. Instead, I'll have this table go through the stock subtable, since both subtables should have the same keys. And then in the print function, I'm going to change cost to stock and add an index for the buy price at the end. After that, I'll just change everywhere the shop items is called so that it instead calls the appropriate subtable in shop items. I also need to update this if statement to check if the number of items in stock is equal to 0. If it is, the shop shouldn't be able to sell items. In addition, the player shouldn't be able to ask for more than the shop has, so I'm adding an else if statement for that to the quantity check. At the transaction receipt, I will add a print statement to confirm the changes to the shop's inventory. Now let's test it and see if it works. I just realized there are multiple places I should have put in new lines, so let me do that real quick. I can confirm that it won't let me buy more than the shop has. Name tag. Let's buy 5 name tags. It'll cost 25 gold for 5 name tags. 25 for what? Cost of a name tag is 5. Interesting. It took the correct balance out of the player's wallet, but it didn't... What? What? That's a weird error. That's a weird bug. Okay, let's investigate this. It will cost 25 gold? No, it should cost 2,500 gold. Because the cost of a name tag, you can even see it right here. Cost is 500. It should cost 25 gold. Hold on. I think I know what I did. I think I know exactly what I did. Yep, I put the number of items in stock instead of the price of the items. Good job. Good job. So I did the transaction correctly, I just put I printed the information wrong. The transaction worked correctly, just the information was not shown correctly. So let's try that one more time to make sure. There we go, 2,500, not 25. There we go. Perfect. Perfect. Next, I need to give the player the ability to sell their own items to the shop. I'll just give the player a random stock of items just like I did for the shop, and now the shop needs to have a set price that they're willing to pay for the items you want to sell. I'll add a sell price subtable to the shop items, and I'll actually add prices for the items the shop has as well as the items they don't. Usually shops will buy items for you for way less than they would sell them, so I'll set the prices to about this much. I might as well add the buy prices for these items because when you sell your items to the shop, they will go into the shop's inventory. I won't add the items to the stock though because that will be managed by the program. Next, I'll add the sell option to the main menu, making sell option 2 and changing exit to option 3. You know, on second thought, I'll make the exit option number an asterisk. There are a lot of programs like bots that take commands in Twitch chats that use an asterisk as a wildcard character. With that logic, it will actually make a lot more sense to use this because any input will exit the program if it's not 1 or 2 to buy or sell. And then also, at the confirmation input, I'll remove the instruction to type N and just leave it as type the lowercase letter y for yes, because it doesn't matter if you press N or anything other than y, because the result will be the same. Now to write the code for the selling function, it's going to look pretty much the same as the code for buying, except it will be in the context of selling the player's inventory instead of the shop's. Now, here's one big thing that will be different from buying. When the shop runs out of any item to sell, they keep that item in their list so they have a record of items they sold. The player, however, will completely remove the item from their inventory in order to make room for more items. This assumes that the player has a limited inventory, which most games do. But most games also don't usually give the shop a limited stock, or sell you back an item for full price after you sold it at half price. Although that kind of scummy thing can happen, even in real-world shops, but I digress. So if the player sells all of an item they have, it will be completely removed from the table. And if the item no longer exists, the receipt will say the number of items remaining in the player's inventory is none. Okay, looking at this right here, I think I want to change something. Everywhere it makes words plural, I'm going to use apostrophe s, because boots with two s's just looks weird. This is why I said earlier that it was almost grammatically correct. It would take a lot more work to make the grammar actually correct, but it all depends on linguistics and what words are used, and all of that is way beyond the scope of this demonstration. Okay, after checking through everything, it seems good to go. Thank you all so much for watching and supporting this tutorial series. I hope this challenge was helpful in understanding how to use parts of Lua I've taught you so far. I can't wait to see what kind of programs you guys created. Remember, a lot of the stuff I've taught you in this chapter can be translated fairly easily to other programming languages. The syntax may not be exactly the same, but the logic is more or less the same for almost everything I've shown you here. These are all just some of the fundamentals of programming in Lua, and this chapter isn't even over yet. Lesson 1-9 will be coming out next week, and it will be covering a little bit on how to fix bugs, specifically the ones that throw errors at you, because those ones are really nice to deal with. If you happen to run into errors with your program and don't understand what they mean, put the error message in the comments along with your code in a pastebin, and I'll do my best to help. If you have any other questions related to this video, please feel free to ask in the comments section as well. I hope to see you all next week.